My name is Courtney and I'm the Creative Services Manager here at Heidelberg, USA. Today, with the help of our demonstration team at the Print Media Performance and Training Center, we're going to take you through the production of our annual wrapping paper. We thought this video might be helpful for you as an employee who might not always be involved with print to better understand the printing process, how the demo room works and operates, and learn about the different equipment.
The first step in the wrapping paper is, of course, the design. The Creative Services team uses Adobe software to create our design files. Our first step is to create a 36-inch by 24-inch artboard, which will be the final size of our wrapping paper. We also make sure to add bleed. Bleed simply means that when we create our design, it will bleed over the trim line, which is where the paper is cut. We do this to avoid a white line when cutting down the paper. When we're creating our pattern, we also have to make sure our color mode is in CMYK, which means cyan, magenta, yellow, and black. CMYK is the color mode that is used for files that are designed to be printed. A printing press creates images by combining CMYK colors to varying degrees with physical ink. Now that we are finished with the design, we will go over the pre-press portion of our project. This means the process and imposition of the job before we actually print. Let's head over to the Prinect area of the Print Media Performance and Training Center, where Sean will walk you through this process.
Hi, I'm Sean White, and I'm the manager of Prinect integration here in the demo room. To produce the 2022 holiday wrapping paper, we used Prinect. You might be wondering, what exactly is Prinect? Well, Prinect is Heidelberg's software solution for a print shop's entire manufacturing process, bringing the Management Information System, or MIS, and production into one integrated system. We started by entering all the job-relevant data into Prinect Business Manager. With this piece of software, we produced a cost-based estimate, quote, created a job, generated a job ticket, and exported all of that data into production. Then, Prinect Production Manager, another component of the software, receives that information and automatically creates a production job, including a process network of actions and connected machines, as well as the necessary data for the layout, all without any intervention from an operator. The file was automatically pre-flighted and prepared for production by the software and then directed back to the portal where the page-level approvals were completed, prompting production that they were ready to output. Using Prinect SignaStation, which is the layout component of the software, I verified the data that was input back in the estimate and transferred to the job. The layout data is a vital part in presetting the Speedmaster press. Ensuring that the data is accurate further reduces touch points from operators downstream. With the layout now complete, we output the job to plate imaging on the Heidelberg Supersetter, as well as automatically transferring all job data seamlessly to the Speedmaster press, which will optimize the make-ready of the print run. But one more point to make. As the operators interact with the job on the machines downstream, that data will automatically be sent back into a component called Analyze Point for production and quality data analysis, as well as feed the MIS with real-time cost data. So let's take a look at the plate imaging process now. The image being fed into the image setter by what we call the APL, the automatic pallet loader. Plates are fed in on demand into the image setter, and then the plates are thermal etched by our laser module with the digital image of each and every color separation. That process takes about a minute to complete. After that, the plate is exported from the supersetter and then rotated and input into the processor. The processor takes the imaged data off the plate and processes it using chemistry. Protects it using a gum, dries it, and then transports it into the bender. The bender is what puts the 90-degree bend into the tail of the plate and then places it on the cart for delivery to the press.
Now that we are done creating the plates, we are ready to place them into our printing press. As you can see, we place each plate into their assigned unit and head over to the press console to begin the job. We will be printing this job on the Speedmaster XL 106 8P plus L. Now, what does all of that even stand for? First, the Speedmaster is the brand name Heidelberg created to represent their offset press product line. Okay, what is an offset press? Offset printing means an image is transferred from a printing plate to a rubber blanket, then onto the final surface such as cardboard, paper, or foil. Now you know what a Speedmaster is, But what do the numbers and letters mean? This specific Speedmaster is an XL model. The 106 represents the max sheet size in centimeters the press is able to run, so 106 centimeters or roughly 41 inches. The 8 tells you that there are 8 printing units. That means that you can print cyan, magenta, yellow, and black ink plus 4 additional inks or coatings. Depending on the press, you may have less or more units. It's dependent upon each shop's unique needs. The P stands for perfector. This means that within the press, you are able to print 4 colors on both sides of the substrate during a single pass. If you did not have a perfector, you would have to run the substrate through the machine twice to print it front and back. Lastly, the L means that there is a coating unit on this machine. It may seem strange that this is represented by an L, but since we are a German company, the L simply stands for the word lacquer. For this job, we will not be using any coating, but a variety of our jobs do. Coating is just a clear embellishment option added to printed pieces to make things pop or just for protection. With our push-to-stop technology, operators can easily press start and all 5 jobs are released simultaneously to the press console. Push-to-stop is the manufacturing philosophy created by Heidelberg to show the ease of use when using our press technology and show its efficiency on the operator's side. After pushing start, the first job is now loaded with its specific job data like format size and color settings, and the plates are mounted to the press. Now, our first job is ready to go. We begin at the feeder. This is where the paper is suctioned up by suction feeder heads and begins its journey through the press. Once it is picked up and in the press, it goes unit by unit to lay down the 4 different inks until the final design is complete. In this configuration, we are printing up to 18,000 sheets per hour. The paper finishes its route at the end of the press, which is called the delivery. With push-to-stop technology, the press will change over to the second job, or in this case, the second design of the wrapping paper, automatically. As long as the paper, inks, and plates are ready, the operator simply needs to press stop to stop the press, aka push to stop. Now we have 5 different wrapping papers. However, we still have one more important step. Next, we'll take our finished printed sheets over to the Polar cutter. Who is Polar? Polar is our commercial post-press partner. The machine we'll be using to cut down our paper is the 54-inch wide guillotine cutter, the Polar N137 AT HD model, which is also configured as a Polar Cutting System200, which will cut down the paper according to the trim marks that we printed onto the sheet itself. This cutter is part of the N series. The 137 represents the width of the machine, so this one in particular is 137 centimeters wide. This cutter is also an AT HD model, which means that there is a 21.5-inch touchscreen with real-life display, and it also has an automatic waste disposal feature during the cutting process. The Cutting System200 means that this cutter also has additional equipment added on to alleviate the workload of the operators using it. This includes a stack lift that allows the transportation of the material to the height of the jogger. The jogger will arrange the cutting material precisely for accurate cut registration, and after cutting, the Transimat unloader places the finished cut substrate onto a pallet.
And now our paper is officially complete and ready to be used. We hope you enjoyed this video and hopefully learned something new. We know that there are a lot of terms and equipment to remember, but know that our demo room is here to help educate and support with any questions you may have. Thanks for watching and happy holidays.